Paper of the day is Reducing the Storage Overhead of Main-Memory OLTP Databases with Hybrid Indexes. It's a 2016 paper. Looking at the summary, using indexes for query execution is crucial for achieving high performance in modern online transaction processing databases. For a main memory database, however, these indexes consume a large fraction of the total memory available and are thus a major source of storage overhead of in-memory databases. To reduce this overhead, paper proposes using a two-stage index. The first stage ingests all incoming entries and is kept small for fast read and write operations. The index periodically migrates entries from the first stage to the second, which uses a more compact, read-optimized data structure. Paper first contribution is hybrid storage, a dual-stage index architecture that achieves both the space efficiency and high performance. Second contribution is dual-stage transformer, DST in short, a set of guidelines for converting any order-preserving index structure into a hybrid index. Third contribution is applying DST to four popular order-preserving index structures like B plus tree, mass tree, skip lists, and ART, and evaluating them in both standalone micro benchmarks and a full in-memory DBMS using several transaction processing workloads. Results show that hybrid indexes provide comparable throughput to the original ones while reducing the memory overhead by up to 70%. Now let's look at the benchmark. Paper evaluates hybrid indexes in two steps. First, they evaluate hybrid index as standalone key value data structure using YCSB-based micro benchmarks. Second, they evaluate hybrid indexes inside EdgeStore and a state-of-the-art main memory OLTP database systems. They replace the default STX P plus tree with the corresponding transformed hybrid indexes and evaluate the entire DBMS end-to-end. They used a set of YCSB-based micro benchmarks to mimic OLTP index workloads. The Yahoo Cloud Serving Benchmark, YCSB in short, approximates typical large-scale cloud services. They used its default workloads A, read-write around 50-50, C, read-only, and E, scan-insert 95 and 5% with Zipfian distributions, which have skewed access patterns common to typical OLTP workloads. Now let's look at the contributions of the paper. First, they propose hybrid index, a dual-stage index architecture that can improve the memory efficiency of indexes in main memory OLTP databases. Second, they introduce DST, a set of guidelines that includes simple dynamic to static transformation to help design hybrid indexes from existing index data structures. Third, they apply DST to four index structures and show the effectiveness and generality of their method. Finally, the dual-stage architecture provides the opportunity to use compact compressed static data structures for database indexing. Now let's give this paper a PS score. Overall, it's a very nice and engaging read, so it gets 10 out of 10 on readability. With 15 pages long, it scores 8 out of 10 on length. Reproducibility and repeatability shouldn't be too challenging, so it gets 9 out of 10. Industry value and learning meter is pretty high, so it gets 9 out of 10 on each. Overall PS score is 9 out of 10.